Item 421. Hydraulic cement concrete. 1. Description. Furnish hydraulic cement concrete for concrete pavements, concrete structures, and other concrete construction. 2. Materials. Use materials from pre-qualified sources listed on the department website. Provide coarse and fine aggregates from sources listed in the department's concrete rated source quality catalog, CRSQC. Use materials from non-listed sources only when tested and approved by the engineer before use. Allow 30 calendar days for the engineer to sample, test, and report results for non-listed sources. Do not combine approved material with unapproved material. 2.1 Cement. Furnish cement conforming to DMS 4600, hydraulic cement. 2.2 Supplementary cementing materials, SCM. Fly ash. Furnish fly ash, ultrafine fly ash, UFFA, and modified Class F fly ash, MFFA, conforming to DMS 4610, fly ash. Slag cement. Furnish slag cement conforming to DMS 4620, slag cement. Silica fume. Furnish silica fume conforming to DMS 4630, silica fume. Metakaolin. Furnish metakaolin conforming to DMS 4635, metakaolin. 2.3 Cementitious material. Cementitious materials are the cement and supplementary cementing materials used in concrete. 2.4 Chemical admixtures. Furnish admixtures conforming to DMS 4640, chemical admixtures for concrete. 2.5 Water. Furnish mixing and curing water that is free from oils, acids, organic matter, or other deleterious substances. Water from municipal supplies approved by the Texas Department of Health will not require testing. Provide test reports showing compliance with Table 1 before use when using water from other sources. Water that is a blend of concrete wash water and other acceptable water sources, certified by the concrete producer as complying with the requirements of both Table 1 and Table 2, may be used as mix water. Test the blended water weekly for 4 weeks for compliance with Table 1 and Table 2 or provide previous test results. Then test every month for compliance. Provide water test results upon request. Table 1. Chemical limits for mix water. See table in specifications. Table 2. Acceptance criteria for questionable water supplies. See table in specifications. 1. Base comparisons on fixed proportions and the same volume of test water compared to the control mix using 100% potable water or distilled water. 2. Base comparisons on sets consisting of at least 2 standard specimens made from a composite sample. Do not use mix water that has an adverse effect on the air entraining agent, on any other chemical admixture, or on strength or time of set of the concrete. Use mixing and curing water free of iron and other impurities that may cause staining or discoloration when using white hydraulic cement. 2.6 Aggregate. 2.6.1 Coarse aggregate. Provide coarse aggregate consisting of durable particles of gravel, crushed blast furnace slag, recycled crushed hydraulic cement concrete, crushed stone, or combinations which are free from frozen material and from injurious amounts of salt, alkali, vegetable matter, or other objectionable material, either free or as an adherent coating. Provide coarse aggregate of uniform quality throughout. Provide coarse aggregate with the requirements listed in Table 3 unless otherwise shown on the plans. Table 3. Coarse aggregate requirements. See table in specifications. 1. Recycled crushed hydraulic cement concrete is not subject to 5-cycle magnesium sulfate soundness requirements. 2. Allowed when air-entrained concrete is used at the contractor's option. 3. Only when air-entrained concrete is required by the plans. Increase the loss by decantation limit to 3% for all classes of concrete and 5% for Class A, B, and P if the material finer than the number 200 sieve is determined to be at least 85% calcium carbonate in accordance with TxDOT 406A, Part 3, in the case of coarse aggregates made primarily from crushing stone unless otherwise shown on the plans. Provide test results upon request. Provide coarse aggregate or combination of aggregates conforming to the gradation requirements shown in Table 4 when tested in accordance with TxDOT 401A unless otherwise specified. Table 4. Coarse aggregate gradation chart. See table in specifications. 1 corresponding ASTM C33 gradation shown in parentheses. 2.6.2 Fine aggregate. Provide fine aggregate consisting of clean, hard, durable particles of natural, manufactured sand, recycled crushed hydraulic cement concrete, slag, lightweight aggregate, or a combination thereof. Provide fine aggregate free from frozen material and from injurious amounts of salt, alkali, vegetable matter, or other objectionable material. Provide fine aggregates with the requirements in Table 5 unless otherwise shown on the plans. Table 5. Fine aggregate requirements. See table in specifications. 1 Only when air-entrained concrete is specified. Provide fine aggregate or combinations of aggregates conforming to the gradation requirements shown in Table 6 when tested in accordance with TxDOT 401A unless otherwise specified. Table 6. Fine aggregate gradation chart, Grade 1. Sieve size and percent passing. Sieve size 3/8 inches with 100% passing. Sieve size number 4 with 95% to 100% passing. Sieve size number 8 with 80% to 100% passing. Sieve size number 16 with 50% to 85% passing. Sieve size number 30 with 25% to 65% passing. Sieve size number 50 with 10% to 35% passing. See Note 1. Sieve size number 100 with 0% to 10% passing. Sieve size number 200 with 0% to 3% passing. See Note 2. 16% to 35% when sand equivalent value is greater than 85%. 20% to 6% for manufactured sand. 2.6.3 Intermediate aggregate. Provide intermediate aggregate consisting of clean, hard, durable particles of natural, manufactured sand, slag, recycled crushed hydraulic cement concrete, lightweight aggregate, or a combination thereof when optimized aggregate gradation, OAG, concrete is specified or when used at the contractor's option. Provide intermediate aggregate free from frozen material and injurious amounts of salt, alkali, vegetable matter, or other objectionable material. Provide intermediate aggregate with the requirements in Table 7. Table 7. Intermediate aggregate requirements. See table in specifications. 1 Only applies to the portion retained on the number 4 sieve, if more than 30% of the intermediate aggregate is retained on the number 4 sieve. 2 Recycled crushed hydraulic cement concrete is not subject to 5-cycle magnesium sulfate soundness requirements. 3 Allowed when air-entrained concrete is used at the contractor's option. 4 Only when air-entrained concrete is required by the plans. 5 Only applies to the portion passing the 3/8 inches sieve, if more than 30% of the intermediate aggregate is passing the 3/8 inches sieve. For the portion retained on the number 4 sieve, if more than 30% of the intermediate aggregate is retained on the number 4 sieve, and in the case of aggregates made primarily from crushing stone, unless otherwise shown on the plans, the loss by decantation may be increased to 3% for all classes of concrete and 5% for Class A, B, and P if the material finer than the number 200 sieve is determined to be at least 85% calcium carbonate in accordance with TxDOT 406A, Part 3. Provide test results upon request. 2.7 Mortar and grout. Furnish pre-packaged grouts conforming to DMS 4675, cementitious grouts and mortars for miscellaneous applications, when specified for applications other than post-tension grouting. Section 421.4.2.6, Mix Design Options, does not apply for mortar and grout. 2.8 Storage of materials. 2.8.1 Cement and supplementary cementing materials. Store all cement and supplementary cementing materials in weatherproof enclosures that will protect them from dampness or absorption of moisture. When permitted, small quantities of packaged cementitious material may be stored in the open, on a raised platform, and under waterproof covering for up to 48 hours. 2.8.2 Aggregates. Handle and store concrete aggregates in a manner that prevents contamination with foreign materials. Clear and level the sites for the stockpiles of all vegetation if the aggregates are stored on the ground, and do not use the bottom 6 inches layer of aggregate without cleaning the aggregate before use. Maintain separate stockpiles and prevent intermixing when conditions require the use of 2 or more grades of coarse aggregates. Separate the stockpiles using physical barriers where space is limited. Store aggregates from different sources in different stockpiles unless the engineer authorizes pre-blending of the aggregates. Minimize segregation in stockpiles. Remix and test stockpiles when segregation is apparent. Sprinkle stockpiles to control moisture and temperature as necessary. Maintain reasonably uniform moisture content in aggregate stockpiles. 2.8.3 Chemical admixtures. Store admixtures in accordance with manufacturer's recommendations and prevent admixtures from freezing. 3. Equipment. 3.1 Concrete plants and mixing equipment. Except for volumetric stationary plant or truck, auger, mixers, each plant and truck mixer must be currently certified by the National Ready Mixed Concrete Association, NREMCA, or have an inspection report signed and sealed by a licensed professional engineer showing concrete measuring, mixing, and delivery equipment meets all requirements of ASTM C94. A new certification or signed and sealed report is required every time a plant is moved. Plants with a licensed professional engineer's inspection require re-inspection every 2 years. Provide a copy of the certification or the signed and sealed inspection report to the engineer. Remove equipment or facilities from service until corrected when they fail to meet specification requirements. When allowed on the plans or by the engineer, for concrete classes not identified as structural concrete in Table 8 or for Class C concrete not used for bridge class structures, the engineer may inspect and approve all plants and trucks instead of the NREMCA or non-department engineer sealed certifications. The criteria and frequency of engineer approval of plants and trucks is the same used for NREMCA certification. Inspect and furnish inspection reports on the condition of blades and fins and their percent wear from the original manufacturer's design for truck mixers and agitators annually. Repair mixing equipment exhibiting 10% or more wear before use. If an inspection within 12 mo is not practical, a 2 mo grace period, for a maximum of 14 mo between inspections, is permitted. 3.1.1 Scales. Check all scales before beginning of operations, after each move, or whenever their accuracy or adequacy is questioned, and at least once every 6 mo immediately correct deficiencies, and recalibrate. Provide a record of calibration showing scales in compliance with ASTM C94 requirements. Check batching accuracy of volumetric water batching devices at least every 90 days. Check batching accuracy of chemical admixture dispensing devices at least every 6 mo. Perform daily checks as necessary to ensure measuring accuracy. 3.1.2 Volumetric mixers. Provide volumetric mixers with rating plates defining the capacity and the performance of the mixer in accordance with the Volumetric Mixer Manufacturers Bureau or equivalent. Provide volumetric mixers that comply with ASTM C685. Provide test data showing mixers meet the uniformity test requirements of TEX 472A. Unless allowed on the plans or by the engineer, volumetric truck, auger, mixers may not supply classes of concrete identified as structural concrete in Table 8. 3.1.3 Agitators and truck and stationary mixers. Provide stationary and truck mixers capable of combining the ingredients of the concrete into a thoroughly mixed and uniform mass and capable of discharging the concrete so at least 5 of the 6 requirements of TEX 472A are met. Perform concrete uniformity tests on mixers or agitators in accordance with TEX 472A as directed, to resolve issues of mix uniformity and mixer performance. Perform the mixer or agitator uniformity test at the full rated capacity of the equipment. Remove all equipment that fails the uniformity test from service. Inspect and maintain mixers and agitators. Keep them free of concrete buildup and repair or replace worn or damaged blades or fins. Ensure all mixers have a plate affixed showing manufacturer's recommended operating speed and rated capacity for mixing and agitating. 3.2 Hauling equipment. Provide hauling equipment capable of maintaining the mixed concrete in a thoroughly mixed and uniform mass, and discharging the concrete with a satisfactory degree of uniformity. Provide equipment with smooth, mortar-tight metal containers equipped with gates that prevent accidental discharge of the concrete when using non-agitating equipment for transporting concrete. Maintain hauling equipment clean and free of built-up concrete. 3.3 Testing equipment. Furnish and maintain the following in accordance with the pertinent test procedure unless otherwise shown on the plans or specified. Sieves necessary to perform aggregate gradation analysis when optimized aggregate gradation is specified. Equipment necessary to perform TEX 415A and TEX 422A. Equipment necessary to perform TEX 409A or TEX 425A. Test molds. Curing facilities. Maturity meters if used, and wheelbarrow or other container acceptable for the sampling of the concrete. Provide strength testing equipment when required in accordance with the contract controlling test unless shown otherwise. For construction. 4.1 Classification of concrete mix designs. Provide classes of concrete meeting the requirements shown in Table 8. A higher strength class of concrete with equal or lower water to cementitious material, with cm, ratio may be substituted for the specified class of concrete when approved. 4.2 Mix design proportioning. Furnish mix designs using ACI 211, TEX 470A, or other approved procedures for the classes of concrete listed in Table 8 unless a design method is indicated on the plans. Perform mix design proportioning by absolute volume method unless otherwise approved. Perform cement replacement using equivalent weight method unless otherwise approved. Do not exceed the maximum with cm ratio listed in Table 8 when designing the mixture. 4.2.1 Cementitious materials. Do not exceed 700 pounds of cementitious material per cubic yard of concrete unless otherwise specified or approved. Use cement of the same type and from the same source for monolithic placements. Do not use supplementary cementing materials when white hydraulic cement is specified. Table 8. Concrete classes. See table in specifications. 1. Design strength must be attained within 56 days. 2. Do not use grade 1 coarse aggregate except in massive foundations with 4 inches minimum clear spacing between reinforcing steel bars, unless otherwise permitted. Do not use grade 1 aggregate in drilled shafts. 3. Use grade 8 aggregate in extruded curbs unless otherwise approved. 4. Other grades of coarse aggregate may be used in non-structural concrete classes when allowed by the engineer. 5. For information only. 6. Structural concrete classes. 7. Do not use Type 1T cements containing 5% limestone. 8. As shown on the plans or specified. 9. X denotes class of concrete shown on the plans or specified. 10. HPC high performance concrete, SRC sulfate resistant concrete. 11. Same as class of concrete shown on the plans. 4.2.2 Aggregates. Recycled crushed hydraulic cement concrete may be used as a coarse or fine aggregate in Class A, B, E, and P concrete. Limit recycled crushed concrete fine aggregate to a maximum of 20% of the fine aggregate. Use light-colored aggregates when white hydraulic cement is specified. Use fine aggregate with an acid-insoluble residue of at least 60% by weight when tested in accordance with TxDOT 612J in all concrete subject to direct traffic. Use the following equation to determine if the aggregate combination meets the acid-insoluble residue requirement when blending fine aggregate or using an intermediate aggregate. See formula in specifications. Where a 1 equals acid-insoluble, percent, of fine aggregate 1. A 2 equals acid-insoluble, percent, of fine aggregate 2. AIA equals acid-insoluble, percent, of intermediate aggregate passing the 3/8 inches sieve. P1 equals percent by weight of fine aggregate 1 of the fine aggregate blend. P2 equals percent by weight of fine aggregate 2 of the fine aggregate blend. PA equals percent by weight of intermediate aggregate passing the 3/8 inches sieve. Alternatively to the above equation, blend fine aggregate with a microdevol loss of less than 12%, when tested in accordance with TxDOT 461A, with at least 40% of a fine aggregate with an acid-insoluble residue of at least 60%. 4.2.3 Chemical admixtures. Do not use Type C, Type E, Type F, or Type G admixtures in Class S bridge deck concrete. Do not use chemical admixtures containing calcium chloride in any concrete. Use a 30% calcium nitrite solution when a corrosion-inhibiting admixture is required. The corrosion-inhibiting admixture must be set neutral unless otherwise approved. Dose the admixture at the rate of gallons of admixture per cubic yard of concrete shown on the plans. 4.2.4 Air entrainment. Use an approved air entraining admixture when air entrained concrete is specified, or when an air entraining admixture is used at the contractor's option, and do not exceed the manufacturer's recommended dosage. Ensure the minimum entrained air content is at least 3% for all classes of concrete except Class P when air entrained concrete is specified, during trial batch, or when providing previous field data. 4.2.5 Slump. Provide concrete with a slump in accordance with Table 9 unless otherwise specified. When approved, the slump of a given concrete mix may be increased above the values shown in Table 9 using chemical admixtures, provided the admixture treated concrete has the same or lower water to cementitious material ratio and does not exhibit segregation or excessive bleeding. Request approval to exceed the slump limits in Table 9 sufficiently in advance for proper evaluation by the engineer. Perform job control testing of slump in accordance with Section 421.4.8.3.1, Job Control Testing. Table 9. Placement slump requirements. See table in specifications. 1 for information only. 2 for fiber reinforced concrete, perform slump before addition of fibers. 4.2.6 Mix design options. 4.2.6.1 Option 1. Replace 20% to 35% of the cement with Class F fly ash. 4.2.6.2 Option 2. Replace 35% to 50% of the cement with slag cement or MFFA. 4.2.6.3 Option 3. Replace 35% to 50% of the cement with a combination of Class F fly ash, slag cement, MFFA, UFFA, metakaolin, or silica fume. However, no more than 35% may be fly ash, and no more than 10% may be silica fume. 4.2.6.4 Option 4. Use Type 1P, Type 1s, or Type 1T cement as allowed in Table 5 for each class of concrete. Up to 10% of a Type 1P, Type 1s, or Type 1T cement may be replaced with Class F fly ash, slag cement, or silica fume. Use no more than 10% silica fume in the final cementitious material mixture if the Type 1T cement contains silica fume, and silica fume is used to replace the cement. 4.2.6.5 Option 5. Replace 35% to 50% of the cement with a combination of Class C fly ash and at least 6% of silica fume, UFFA, or metakaolin. However, no more than 35% may be Class C fly ash, and no more than 10% may be silica fume. 4.2.6.6 Option 6. Use a lithium nitrate admixture at a minimum dosage determined by testing conducted in accordance with TxDOT 471A. Before use of the mix, provide an annual certified test report signed and sealed by a licensed professional engineer, from a laboratory on the department's MPL, certified by the construction division as being capable of testing according to TxDOT 471A. 4.2.6.7 Option 7. Ensure the total alkali contribution from the cement in the concrete does not exceed 3.5 pounds per cubic yard of concrete when using hydraulic cement not containing SCMs calculated as follows. In the above calculation, use the maximum cement alkali content reported on the cement mill certificate. 4.2.6.8 Option 8. Perform annual testing as required for any deviations from options 1 to 5 or use mixed design options listed in Table 10. Laboratories performing ASTM C1260, ASTM C1567, and ASTM C1293 testing must be listed on the department's MPL. Before use of the mix, provide a certified test report signed and sealed by a licensed professional engineer demonstrating the proposed mixture conforms to the requirements of Table 10. Provide a certified test report signed and sealed by a licensed professional engineer, when HPC is required, and less than 20% of the cement is replaced with SCMs, demonstrating ASTM C1202 test results indicate the permeability of the concrete is less than 1,500 coulombs tested immediately after either of the following curing schedules. Moisture cure specimens 56 days at 73 degrees Fahrenheit. Moisture cure specimens 7 days at 73 degrees Fahrenheit followed by 21 days at 100 degrees Fahrenheit. Table 10. Option 8 Testing and Mix Design Requirements. See Table in Specifications. 1. Do not use Class C fly ash if the ASTM C1260 value of the fine, intermediate, or coarse aggregate is 0.3% or greater, unless the fly ash is used as part of a ternary system. 2. Intermediate size aggregates will fall under the requirements of mix design coarse aggregate. 3. Average the CaO content from the previous 10 values as listed on the mill certificate. 4.2.7 Optimized aggregate gradation, OAG, concrete. The gradation requirements in Table 3 and Table 4 do not apply when OAG concrete is specified or used by the contractor unless otherwise shown on the plans. Use TxDOT 470A to establish the optimized aggregate gradation. Use at least 420 pounds per cubic yard of cementitious material when OAG concrete is used unless otherwise approved. Use a coarse aggregate with a maximum nominal size of 1.5 inches for Class P concrete. Use a coarse aggregate for all other classes of concrete with a maximum nominal size not larger than 1/5 the narrowest dimension between sides of forms, or 1/3 the depth of slabs, or 3/4 the minimum clear spacing between individual reinforcing bars or wires, bundles of bars, individual tendons, bundled tendons, or ducts. Make necessary adjustments to individual aggregate stockpile proportions during OAG concrete production when the gradation deviates from the optimized gradation requirements. 4.2.8 Self-consolidating concrete, SCC. Provide SCC meeting the following requirements shown in Table 11 when approved for use in precast concrete. Use concrete with a slump flow that can be placed without vibration and will not segregate or excessively bleed. Request approval to exceed the slump flow limits sufficiently in advance for proper evaluation by the engineer. Table 11. Mix design requirements for SCC. See Table in Specifications. 1. These slump flow limits are generally acceptable for most applications. However, slump flow limits may be adjusted during mix design approval process and when approved by the engineer. 4.3 Concrete trial batches. Perform preliminary and final trial batches when required by the plans, or when previous satisfactory field data is not available. Submit previous satisfactory field data to the engineer showing the proposed mix design conforms to specification requirements when trial batches are not required and before concrete is placed. Perform preliminary and final trial batches for all self-consolidating concrete mix designs. 4.3.1 Preliminary trial batches. Perform all necessary preliminary trial batch testing when required, and provide documentation including mix design, material proportions, and test results substantiating the mix design conforms to specification requirements. 4.3.2 Final trial batches. Make all final trial batches using the proposed ingredients in a mixer that is representative of the mixers to be used on the job when required. Make the batch size at least 50% of the mixer's rated capacity. Perform fresh concrete tests for air content and slump, and make, cure, and test strength specimens for compliance with specification requirements. Test at least one set of design strength specimens, consisting of 2 specimens per set, at 7-day, 28-day, and at least one additional age unless otherwise directed. Before placing, provide the engineer the option of witnessing final trial batches, including the testing of the concrete. If not provided this option, the engineer may require additional trial batches, including testing, before the concrete is placed. Conduct all testing listed in Table 11 when performing trial batches for self-consolidating concrete. Make an additional mixture with 3% more water than the preliminary trial batch. Make necessary adjustments to the mix design if this additional mixture does not meet requirements of Table 11. Cast and evaluate mock UPS for precast concrete that are representative of the actual product as directed. Provide the engineer the option of witnessing final trial batches, including the testing of the concrete and the casting of the mock UPS before placement. If not provided this option, the engineer may require additional trial batches, including testing and mock UPS, before the concrete is placed. Establish 7-day compressive strength target values using the following formula for each Class A, B, and E concrete mix designs to be used. Submit previous satisfactory field data, data from a new trial batch, or other evidence showing the change will not adversely affect the relevant properties of the concrete when changes are made to the type, brand, or source of aggregates, cement, SCM, water, or chemical admixtures. Submit the data for approval before making changes to the mix design. A change in vendor does not necessarily constitute a change in materials or source. The engineer may waive new trial batches when there is a prior record of satisfactory performance with the ingredients. During concrete production, dosage changes of chemical admixtures used in the trial batches will not require a re-evaluation of the mix design. The contractor has the option of performing trial batches in conjunction with concrete placements except for SCC mixtures, when new trial batches are required during the course of the project. If the concrete fails to meet any requirement, the engineer will determine acceptability and payment adjustments. Establish the strength, maturity relationship in accordance with Text 426A when the maturity method is specified or permitted. When using the maturity method, any changes in any of the ingredients, including changes in proportions, will require the development of a new strength, maturity relationship for the mix. 4.3.3 Mix design of record. Once a trial batch or previously satisfactory field data substantiates the mix design, the proportions and mixing methods used become the mix design of record. Do not exceed mix design water to cementitious material ratio. 4.4 Production testing. 4.4.1 Aggregate moisture testing. Determine moisture content per Text 409A or Text 425A for coarse, intermediate, and fine aggregates at least twice a week, when there is an apparent change, or for new shipments of aggregate. When aggregate hoppers or storage bins are equipped with properly maintained electronic moisture probes for continuous moisture determination, moisture tests per Text 409A or Text 425A are not required. Electronic moisture probes, however, must be verified at least every 90 days against TxDOT 409A and be accurate to within 1% of the actual moisture content. When producing SCC, and when aggregate hoppers or storage bins are not equipped with electric moisture probes, determine the moisture content of the aggregates before producing the first concrete batch each day. Thereafter, determine the moisture content every 4 hours or when there is an apparent change while SCC is being produced. 4.4.2 Aggregate Gradation Testing. Perform a sieve analysis in accordance with TxDOT 401A on each stockpile used in the blend at least 1 day before producing OAG concrete when producing optimized aggregate gradation concrete. Perform sieve analysis on each stockpile after every 10,000 cubic yards of OAG concrete produced. Provide sieve analysis data to the engineer. 4.5 Measurement of materials. 4.5.1 Non-volumetric mixers. Measure aggregates by weight. Correct batch weight measurements for aggregate moisture content. Measure mixing water, consisting of water added to the batch, ice added to the batch, water occurring as surface moisture on the aggregates, and water introduced in the form of admixtures, by volume or weight. Measure ice by weight. Measure cement and supplementary cementing materials in a hopper and on a separate scale from those used for other materials. Measure the cement first when measuring the cumulative weight. Measure concrete chemical admixtures by weight or volume. Measure batch materials within the tolerances of Table 12. Table 12. Mix design batching tolerances non-volumetric mixers. See table in specifications. 1 Allowable deviation from target weight not including water withheld or moisture in the aggregate. The engineer will verify the water to cementitious material ratio is within specified limits. Ensure the quantity measured, when measuring cementitious materials at less than 30% of scale capacity, is accurate to not less than the required amount and not more than 4% in excess. Ensure the cumulative quantity, when measuring aggregates in a cumulative weigh batcher at less than 30% of the scale capacity, is measured accurate to plus or minus 0.3% of scale capacity or plus or minus 3% of the required cumulative weight, whichever is less. Measure cement in number of bags under special circumstances when approved. Use the weights listed on the packaging. Weighing bags of cement is not required. Ensure fractional bags are not used except for small hand-mixed batches of approximately 5 cu feet or less and when an approved method of volumetric or weight measurement is used. 4.5.2 Volumetric mixers. Provide an accurate method of measuring all ingredients by volume, and calibrate equipment to assure correct measurement of materials within the specified tolerances. Base tolerances on volume, weight relationship established by calibration, and measure the various ingredients within the tolerances of Table 13. Correct batch measurements for aggregate moisture content. Table 13. Mix design batching tolerances volumetric mixers. See table in specifications. 4.6 Mixing and delivering concrete. 4.6.1 Mixing concrete. Operate mixers and agitators within the limits of the rated capacity and speed of rotation for mixing and agitation as designated by the manufacturer of the equipment. Provide concrete in a thoroughly mixed and uniform mass with a satisfactory degree of uniformity when tested in accordance with TxDOT 472A. Do not top-load new concrete onto returned concrete. Adjust mixing times and batching operations as necessary when the concrete contains silica fume to ensure the material is completely and uniformly dispersed in the mix. The dispersion of the silica fume within the mix will be verified by the Construction Division, Materials and Pavements section, using cylinders made from trial batches. Make necessary changes to the batching operations, if uniform dispersion is not achieved, until uniform and complete dispersion of the silica fume is achieved. Mix concrete by hand methods or in a small motor-driven mixer when permitted, for small placements of less than 2 CUYD. For such placements, proportion the mix by volume or weight. 4.6.2 Delivering concrete. Deliver concrete to the project in a thoroughly mixed and uniform mass, and discharge the concrete with a satisfactory degree of uniformity. Conduct testing in accordance with TxDOT 472A when there is a reason to suspect the uniformity of concrete and as directed. Maintain concrete delivery and placement rates sufficient to prevent cold joints. Adding chemical admixtures or the portion of water withheld is only permitted at the job site, under the supervision of the engineer, to adjust the slump or slump flow of the concrete. Do not add water or chemical admixtures to the batch after more than an amount needed to conduct slump testing has been discharged. Turn the drum or blades at least 30 additional revolutions at mixing speed to ensure thorough and uniform mixing of the concrete. When this water is added, do not exceed the approved mix design water to cementitious material ratio. Before unloading, furnish the delivery ticket for the batch of concrete containing the information required on Department Form 596, Concrete Batch Ticket. The engineer will verify all required information is provided on the delivery tickets. The engineer may suspend concrete operations until the corrective actions are implemented if delivery tickets do not provide the required information. The engineer will verify the design water to cementitious material ratio is not exceeded. Begin the discharge of concrete delivered in truck mixers within the times listed in Table 14. Concrete may be discharged after these times provided the concrete temperature and slump meet the requirements listed in this item and other pertinent items. Perform these tests with certified testing personnel per Section 421.4.8.1, Certification of Testing Personnel. Provide the engineer the option of witnessing testing of the concrete. If not provided this option, the engineer may require additional testing before the concrete is placed. Table 14. Concrete discharge times. See table in specifications. 1 concrete must contain at least the minimum manufacturer's recommended dosage of type B or D admixture. 4.7 Placing, finishing, and curing concrete. Place, finish, and cure concrete in accordance with the pertinent items. 4.8 Sampling and testing of concrete. Unless otherwise specified, all fresh and hardened concrete is subject to testing as follows. 4.8.1 Certification of testing personnel. Contractor personnel performing testing must be either ACI certified or qualified by a department-recognized equivalent written and performance testing program for the tests being performed. Personnel performing these tests are subject to department approval. Use of a commercial laboratory is permitted at the contractor's option. All personnel performing testing using the maturity method must be qualified by a training program recognized by the department before using this method on the job. 4.8.2 Fresh concrete. Provide safe access and assistance to the engineer during sampling. Fresh concrete will be sampled for testing at the discharge end if using belt conveyors or pumps. When it is impractical to sample at the discharge end, a sample will be taken at the time of discharge from the delivery equipment and correlation testing will be performed and documented to ensure specification requirements are met at the discharge end. 4.8.3 Testing of fresh concrete. Test for the fresh properties listed in Table 15. Table 15. Fresh concrete tests. See table in specifications. 1 Job control testing performed by the contractor. 2 Only required when air-entrained concrete is specified on the plans. Concrete with a slump lower than the minimum placement slump in Table 9 after the addition of all water withheld, or concrete exhibiting segregation and excessive bleeding will be rejected. 4.8.3.1 Job control testing. Perform job control testing as specified in Table 16 unless otherwise specified. Provide the engineer the opportunity to witness the testing. The engineer may require a retest if not given the opportunity to witness. Immediately notify the engineer of any nonconformity issues. Furnish a copy of all test results to the engineer daily. Table 16. Job control testing frequencies. See table in specifications. Immediately resample and retest the concrete slump when the concrete exceeds the slump range at time of placement. If the concrete exceeds the slump range after the retest, and is used at the contractor's option. The engineer will make strength specimens as specified in Article 421.5, Acceptance of Concrete. 4.8.3.2 Strength Specimen Handling. Remove specimens from their molds and deliver department test specimens to curing facilities within 24 to 48 hours after molding, in accordance with pertinent test procedures unless otherwise shown on the plans or directed. Clean and prepare molds for reuse if necessary. 5. Acceptance of concrete. The engineer will sample and test the fresh and hardened concrete for acceptance. The test results will be reported to the contractor and the concrete supplier. Investigate the quality of the materials, the concrete production operations, and other possible problem areas to determine the cause for any concrete that fails to meet the required strengths as outlined below. Take necessary actions to correct the problem, including redesign of the concrete mix. The engineer may suspend all concrete operations under the pertinent items if the contractor is unable to identify, document, and correct the cause of the low strengths in a timely manner. Resume concrete operations only after obtaining approval for any proposed corrective actions. Concrete failing to meet the required strength as outlined below will be evaluated using the procedures listed in Article 421.6, Measurement and Payment. 5.1 Structural class of concrete. For concrete classes identified as structural concrete in Table 8, the engineer will make and test 7-day and 28-day specimens. Acceptance will be based on attaining the design strength given in Table 8. 5.2 Class P and Class Es. The engineer will base acceptance in accordance with Item 360, Concrete Pavement, and Item 361, Repair of Concrete Pavement. 5.3 All other classes of concrete. For concrete classes not identified as structural concrete in Table 8, the engineer will make and test 7-day specimens. The engineer will base acceptance on the 7-day target value established in accordance with Section 421.4.3, Concrete Trial Batches. 6. Measurement and Payment. The work performed, materials furnished, equipment, labor, tools, and incidentals will not be measured or paid for directly but will be subsidiary to pertinent items. The following procedure will be used to evaluate concrete where one or more project acceptance test specimens fail to meet the required design strength specified in this item or on the plans. The concrete for a given placement will be considered structurally adequate and accepted at full price if the average of all test results for specimens made at the time of placement meets the required design strength, provided no single test result is less than 85% of the required design strength. The engineer will perform a structural review of the concrete to determine its adequacy to remain in service if the average of all test results for specimens made at the time of placement is less than the required design strength, or if any test results are less than 85% of the required design strength. If the in situ concrete strength is needed for the structural review, take cores at locations designated by the engineer in accordance with Text 424A. The engineer will test the cores. The coring and testing will be at the contractor's expense. If all of the tested cores meet the required design strength, the concrete will be paid for at full price. If any of the tested cores do not meet the required design strength, but the average strength attained is determined to be structurally adequate, the engineer will determine the limits of the payment adjustment using the following formula. See formula in specifications. Where A equals amount to be paid per unit of measure for the entire placement in question. SA equals actual average strength from cylinders or cores. Use values from cores, if taken. SS equals minimum required strength, specified. BP equals unit bid price. If the structural review determines the concrete is not adequate to remain in service, the engineer will determine the limits of the concrete to be removed. The decision to reject structurally inadequate concrete or to apply the payment adjustment factor will be made no later than 56 days after placement.